In this one, we are asked to find the value of m in the mapping. So this one, we are looking at how we can find what the image under a given mapping. There are times that there will be a mixing what image. So when we say image, we know that image is what part of the codomain. Okay, yes. So we are looking at the element in the codomain. That is what image. So most of the time we say that the codomain can also be what the image once they have corresponding element in the domain. Then all the elements are also referred to as what the image in the codomain. All right, good. So sometimes you have missing element in the domain. You may also have missing element in the what codomain and asked to find. As we see in this example, you see that we have this m here. We don't know the value here, and we are asked to find it. Anytime you have such questions, what you only do is that first of all, you find the rule of the given mapping. In our previous lessons, we looked at how to find the rule of a linear mapping, exponential mapping, and quadratic mapping. So once we are done with all those rules, then questions like this becomes very easy for us to find those missing values or those image. All right, good. So if that is the case, then let's look at how we can find the rule of the mapping. And as we did earlier, we said that whenever you are given the question, you need to test whether it's a linear, exponential, or quadratic. Okay, so looking at this, if you want to test whether it's a linear, then we can find the difference of the domain and find the difference of the codomain. If you realize that both of them have common difference of their consecutive elements, then we find the rule of a mapping. So if that's the case, then let me test if I have a linear. If it is a linear mapping, then I will just subtract 0 from 2, which gives me what? 2, which is the same as when I subtract 2 from 4, it gives me what? 2. And when I subtract 4 from 6, it gives me 2. The same way when I subtract 6 from 8, it also gives me what? 2. So it means that I'm getting what? A constant value for the as the difference of the domain. Let me also test for the codomain. Let me find the difference. It means that I'm going to subtract 5 from 3, which will give me what? Negative 2. Is it the same as when I subtract 3 from 1? It also gives me what? Negative 2. Then we can also say that we are going to what? Subtract. So it means this should be equal to what? When I subtract 1 from m. Okay, when I subtract 1 from m, it should give me something. And when I subtract, it should be the same as when I subtract m from negative 3. It should give me the same. So you realize that as it is going, when you subtract 5 from 2, you are getting negative. And when you subtract 5 from 3, you are getting negative 2. The same way when you subtract 3 from 1, you are getting negative 2. So you realize that you are getting what? The same or common difference. If that's the case, then you can conclude that this mapping is a linear one. It's a linear one. Then you use what? The rule. You use the rule. Okay. So what rule do we use? We say that for linear mapping, this is the rule given. Ax plus b, where a is given as change in y on what? Change in x, which can be further expressed as y2 minus y1 divided by x2 minus x1, where the y and the x, they are the element in both codomain and what? Domain. Okay, So what will be my y2? I can decide to pick maybe this number and this number. I can decide to pick this number and that number, or this number and that number. Any of them that I will pick, it will work for me. So it means I will pick my y1 as this 5 and pick my y2 as what? 3. Then I'll pick my x1 as 0 and pick my x2 as what? 2. So my A is giving us, so if I'm picking y2, then I can write 3 minus 5, which gives, then my x2, I'm also picking what? 2, which is 2 minus, and then we have what? 0. Okay, x1 is 0, which gives me negative 2 divided by 2, and the answer is what? Negative 1. So it means that my A is negative 1. I can just substitute the A here, which will give me y is equal to negative 1, and then I'm multiplying by x plus my B. Then I will have y is equal to negative x plus B. How do I also find B? Remember, we've done this already. Okay, we know that if we want to find the B, then what we do is that we pick a number for x and y. So we can pick the first one, and then what? We can pick this one, their corresponding element. So it means that when x is equal to 0, y is equal to 5. Good. I will just substitute and find B. So y, which is 5, is equal to 0. That is x, so here is 0 plus B. Then my B is equal to what? 5. So once I get the B, I can substitute the B here in this equation. Then y is equal to negative x plus 5. This is the rule. This is the rule. Alright, good. Now, once you have the rule, then you look at wherever it is missing. You look at wherever it is missing. Then you look at the number and its corresponding what? Missing value. Okay, so you realize that M is missing as the image and the 6 as the what? The domain. So what will be the image of 6? That is what we are looking for. So it means when my x is equal to 6, my y is equal to M. Okay, then I'll substitute and solve for M. So my M, which is the y, is equal to my this, which is what? Negative 6 plus 5. Okay, good. Then my M is equal to negative 1. Okay, so my M is negative 1. It means that the image of this 6 is negative 1. So it means when I put negative 1 here, then I can find the difference. Okay, alright, because when I subtract this from 1 from negative, I'm going to get negative 2, which will satisfy the condition. Okay, if I put negative 1 here the difference will also be negative 2. So that satisfies the condition. Questions like this, that is how we can go about it. Alright, let's see if we can take another example, but this time this example is not going to be on arrow diagram in a form of mapping like this one. Okay, I'm going to take a second example, but it will not be in this form. Alright, good. But whenever you are giving questions in this form, this is how you can go about it. So let's look at a second example which is not in this form, but the same as what? Finding the image. Alright, okay, let's look at the second example. So this one, we have to find the image of 5 on 4 under the mapping defined by x maps onto 12x plus 4. So in this question, we can only find the image of, so looking at this one, you know that this element here, what represent the x values, which is the domain. This is a domain, okay? This is a domain, and we are looking for it corresponding y value, which is what in the codomain, or which is a range. So we are looking for it range at the same time the image, okay? But we can only do that when we substitute this value into the relation. Okay, this is the relation given, that is x. This is what my x, which is a domain. I can only find its image when I substitute this value into the relation. All right, yes, that is the only way I can do that. So it means that let me write my solution first. It means that x is given as what that in the question. Okay, so I will only substitute this value into the relation. It therefore becomes 5 on 4 relate to 12. Then I'll open bracket and write 5 on 4 there plus 4, where we have 5 on 4 relate to so 4 divides itself 1 and divides to 3, so I'll have 3 times 5 plus 4, where I will have my 5 on 4 corresponding to this image, which is 15 plus 4, and then the final answer becomes 5 on 4 is assigned to 19. Okay, so it means that therefore the image of 5/4 or 5 on 4 is 19. So questions like this, that is how we can go about it. Very simple, it's very basic. All right, so when you are given such questions, this is how you solve it. All right, so we shall end here and continue next time. There are a lot of examples that we have to look at. So in our next lesson, we shall be solving different kinds of examples under mapping. So stay cool and wait for the rest of the questions that we'll be solving. Now, this is Mr. Evans. I'm your facilitator. I'm the owner of Mathsways TV. So please don't forget to subscribe, like, and share. Thank you. Bye-bye.